This is RD Sharma Solution, Class 12, Chapter 18, Maxima and Minima. Exercise is 18.3. This is fx is equal to x plus a square by x. Here a should be greater than 0, first requirement. The second requirement is x should not be equal to 0, or this is the condition also. Requirement plus condition. The first step we generally take in local maxima and minima is the differentiation. We are taking the differentiation, that is f dash x we are taking. So this 1 plus a square and 1 by x differentiation is negative 1 by x square. So I have already placed a negative here. Second step is to put or equate f dash x to 0. This f dash x equals to 0. That means 1 is equal to a square by x square is equal to a square. This gives x will be equal to plus minus a, because we have two values here which are the probable or possible points of local minima and local maxima. So this plus and minus, local minima, local maxima. This next step what we take here is to double differentiate. The double differentiation of 1 minus a squared by x squared. We are going to differentiate it again, and since 1 is going to be 0, negative a square by x square, this x goes up, negative 2, and this gives you negative 2x raised minus 3, negative 2 by x cube, and since already there is a negative, the whole result of f dash or f double dash, as you can call it as double prime also, f double prime, and this goes a square by x cube, and this a square by x cube. Please remember a is greater than 0 and x is not equal to 0. Next thing comes is, because these are the critical points, and since a square by x cube, since we have a variable here, one time this variable will be replaced by a, another time negative a square by a cube and a square by negative a cube. Both the time you will get 1 by a, fa with positive 1 by a, f negative a by negative 1 by a. And since it is positive in first case, it's greater than 0, that indicates that you are going to get local minima. This is local minima, positive local minima. And since we have this as negative, you are going to get negative 1 by a here. These are all the cancellations I am doing in front of you. But whole idea is negative 1 by a is less than 0. Less than 0 simply means it's local maximum or local maxima. So we have already found the local minima maxima point at the critical points plus a minus a. Next step is to find out the actual value of y for fx. In this case, x is a and negative a. We have f a and f minus a in the original equation, that is x plus a square by x. So I am replacing in the first equation, basic equation, the question equation, a and negative a, and simply you will get, this is cancellation 2a, this is going to be negative 2a, minus a, this gets cancelled, minus a is minus 2a. We have 2a by negative 2a, and this is the value of local minima and maxima at these critical points of local minima and maxima. So I hope you have a clear understanding here what we are doing, and the next question will also follow the same scheme. Again, these are the content which is to be written, because the writing is more important than you knowing how to solve it. Answer is with the all writing. Okay. Now x under root 2 minus x square. This x should be between negative root 2 and positive root 2. Differentiation is all clear to you. I don't need to tell you again and again, because differentiation we have already done quite a number of times. I'm writing the differentiation. You just have to take the product rule. Once you do this, the second step is f dash x has to be equal to 0. When you place or equate this as equal to 0, this both equal to 0, one will go on the right hand side. So let me do it here only. It will be is equal to. That is, when you have this under root 2 minus x square multiplied, 2 minus x square is x square, 2x square is 2, x square is 1, x will be equal to plus minus 1. X is plus minus 1, that means you have critical points as plus and minus 1. But negative root 2 and root 2 is 1.414. So we are still inside this above said interval. Next step is to find out the double differentiation. We are going to differentiate what we have differentiated earlier. So this is going to be the double differentiation or second derivation. And this is done only for the finding out of the sign at these critical points. That means if I write the double differentiation, it is going to be negative x divided by under root 2 minus x square. And since we have done all the differentiation, a whole chapter we have completed, that's why I am writing it, because this is the differentiation of the differentiation. It is not the original differentiation. And we just have to replace the plus 1 and minus 1 and try to record the sign. What sign, plus or negative, you are going to get. Let us place it here, plus 1 and minus 1, f double dash 1 and f double dash negative 1. This 1 and minus 1, and you can also estimate rather than actually solving it. Just try to find out what sign is going to come. As I said earlier, we are not interested in the value but instead in this sign. F double dash 1 gives you negative 2, that is less than 0. F double dash or double prime negative 1 is 2, which is greater than 0. Negative 2 is local maxima. Negative always gives you local maxima point, and positive will give you local minima point. This is local maxima and local minima. Next step is just to find out the value of the function at these critical points. There is nothing with regards to step 3 and 4. 3 and 4 step is only for the sign, knowing the sign. This fifth step can also be done just after the second step, because once you are aware of the critical points, f1 and f negative 1 has to be placed in the original equation. This original equation, that means we are replacing x by 1 and then negative 1. You can see here I am writing 1 and negative 1 here, and that those values are the actual value of the function at these critical points, which is of course the y point, because y is equal to fx. Fx is the function we are talking about. Y is f1, y is f negative 1. Again, third and fourth step you can just ignore. We don't need to do third and fourth for this, but just for the sake of local minima and maximum we have done it. So now you have known the values. These differentiation have already, because we have already computed it. So just I have written for sake of completion. Otherwise I leave it for you. Next one is x plus under root 1 minus x. X should be less than equal to 1. That means we will check for the value. If it is less than 1, we are going to ignore it. The first step is a differentiation. So we have differentiation 1 by twice of under root 1 minus x, and this is quite clear to you. The second step is simply equating it to 0. Just equate it to 0. I am writing it here only. This is the whole LHS and RHS, left hand side and right hand side. On either side, twice under root 1 minus x is 1. Under root 1 minus x is half. Now you can square it. 1 minus x is 1 by 4. X will be equal to 1 minus 1 by 4. And 1 minus 1 by 4 is simply 4 minus 1 by 4, that is 3 by 4. X gives you 3 upon 4. This is the critical point, and on this critical point we have to check for the local maxima and minima. For that, this third step is mandatory, and this is the double derivative way of solving this question. Double derivative is simply f double dash x. 1 minus 1 by 2 under root 1 minus x has to be differentiated, and since you are already aware of the differentiation, quite often you have done it, this is the double differentiation. Once this is completed, we have to put x equals to 3 by 4, which was computed by f dash equals to 0 when we placed it. This x equals to 3 by 4 has to be replaced in f double dash or f double prime 3 by 4. When you place x equals to 3 by 4, in the third step, you are going to get a negative half. Negative half is simply a negative number, and this negative number, that is less than 0 number, indicates that this is a local maximum point. Local maximum point. This is the fourth step, but the final step can be, third and fourth can be bypassed if you are not asked about local maxima or minima. But once you are aware of the critical point, you have to find out the value of the function at the critical point. And this is by y equals to fx. Replace x by 3 by 4 in x plus under root 1 minus x, which I have done. It will be 5 by 4. This is the step-by-step solution of what I have just explained. English language is very important when you are writing, and this concludes that what you know. This is a repeated question, and this question we have done multiple times. And since we have done it already, you have to multiply it first, then you have to differentiate. And this is I am placing in front of you because this is almost similar to the previous question we have completed. Next one, x under root 1 minus x square. This question also is indicating that we have already done. Since it involves a lot of differentiation, this question also is being completed. But I'm going to explain it to you here itself, because doing it will be the waste of time for those who are actually following all of my videos or all of my discussion. And this is the f dash x. First of all, this differentiation has to be equated to the second step, has to be equated to 0. You will get 1, -1 and -1 by 5. Once you get these three critical value, you have to find out the double dash x, that is the double differentiation. Once you do the double differentiation, you are going to get certain expression. And in this expression, 1 by 1, we have to replace it x by 1, -1 and -1 by 5. When we replace 1, you are going to get what? I am saying f dash is already computed. F dash x equals to 0 gives us the critical point. F double dash x, here we have to place 1, -1 and -1 by 5. And then you see at x equals to 1, we get 0. And whenever we get double dash function value as 0, simply you can say that this is the point of inflection. Since less than 0 and greater than 0, less than 0 and greater than 0 is what gives you local maxima, local minima. But when you have 0, f double dash x equals to 0, negative and positive is nothing. That means you can just say it is a point of inflection. As you remember, negative gives us local maxima, positive gives us local minima. So f double dash x equals to 0. This is the first question we are talking about like this, because point of inflection in the double derivative scenario has never come. And this has come now. Final value has to be computed in the original equation. Now just place x as 1, -1 and -1 by 5 in the original equation, and then find out the value of the function at these critical points. And you don't have to find out for 1 because this is a point of inflection. Don't worry about placing 1. Just -1 and -1 by 5 has to be computed. That is f -1 and f -1 by 5. Local minima at f double dash -1, and that is the point -1. -1 by 5, you are going to get local maxima. So this is the whole scenario. I would really encourage you to do it by yourself. Only differentiation is the key here. This is a different kind of question, and we are going to attempt it. And you don't have to do anything here, what we have discussed earlier. Since only differentiation has to be done and extreme values are already given. Extreme values here are indicating just the critical points which I have been talking about. I have been talking about the critical points which are gained by placing f dash x equals to 0. F dash x is equal to a by x, log x is of course 1 by x, b x square is 2x, and x differentiation is 1. This is f dash x. Now the next thing comes here is we have to place the 1 and 2, because this is the critical points, and critical points will give you f dash x equal to 0. That means placing 1 in the differentiated equation, placing 2 in the differentiated equation has to be equal to 0, and that will give you a and b. How? Critical points already known to us. Extreme values, critical points already known to us. X equals to 1, x equals to 2. So now just take x for 1. This is a by 1 plus 2b into 1 plus 1 equals 0. From here we'll get an expression a plus 2b plus 1. So I'm taking this -2b and -1 on right. Now I'm placing in the differentiated equation first derivative 2. Once I replace x by 2 here, a by 2 plus 2b into 2 plus 1. we again get an equation here. Again, a is equal to negative 8b minus 2. And these two equations will give you a and b because we have two variables and two equations. We don't need any other equation here. Let us solve this. Minus 1 minus 2b is equal to minus 2 minus 8b. Take b constant one side and other constant values on other side. We get 8b minus 2b as 6b. On the right you will get this as negative 1. B is negative 1 by 6. Now this b equals to negative 1 by 6. Replace it in any of the equation 1 and 2. And from here you are going to get a. We will get a here. So this a and b are the values which are asked in this question. B is negative 1 by 6. A is a negative 2 by 3. This is the local minima, local maxima not question. That is, it is not related with local minima maxima. It's something different. And especially for the critical points I'm talking. What are the critical points at which the f dash x equals to 0? F dash equals to 0 is all about the slope of the line. Slope has to be, because this slope when it is parallel to the x-axis, then we say dy by dx is 0. Because a line which is parallel to x-axis or it is x-axis, then only the differentiation should be 0. F dash x or f prime x is nothing but the differentiation only. So this is how you're going to do, and these are the very simple steps that you can follow.